All right, good evening, folks. So this is for pre-calculus. I'll try to link this form down in the comments for us. But one of the worksheets that I gave out said, okay, we have z is equal to negative 3 halves root 3 plus 3 halves I. We would like to compute the quantity z to the fourth. So implicitly, there is a use DeMoivre's rule here. Another kind of implicit instruction here would be write your answer in the form of a plus bi. So we would write this as a plus bi at the end here, okay? So the way I have my students start this, okay, is we have to take a complex number and convert it to polar form, then apply DeMoivre's rule to it, and then figure out what z to the fourth is. So the first step in doing that is to graph a triangle on a real complex axis. Okay, so this is the real axis. This is the imaginary axis. So if I go ahead and do this, the real axis goes 3 halves times root 3. We're just going to call that over here somewhere. Okay, so we could do, this is negative 3 over 2 square root of 3. Okay, just multiply that out. It's going to be like, I don't know, 2.7 or something. And then we're going to go 3 halves. Here's 1, here's 2. So about 3 halves up. That's in the I direction. Okay. And then we'll go ahead and we'll draw a little line to this. Okay, pretend that's straight. And what we have to do is we have to figure out the distance here. Okay, that's the modulus. And then we have to figure out what this angle theta is. Okay. So in order to figure out the modulus, right, if you've gone through high school math, you probably have 3 halves here. So we have a triangle, right? The adjacent side is negative 3 over 2 root 3. The opposite side is negative 3 over 2. We have to figure out the hypotenuse here. Okay, so what we're going to do is say that z, absolute value, is equal to the square root, okay? And we're going to use Pythagorean's theorem here. So it's just going to be negative 3 over 2 times the square root of 3, all in parentheses, squared. Okay. Plus, and then I have a 3 halves for the height squared. Okay, and that's going to be our hypotenuse there. Now, this is a little tricky. Okay, 3 halves squared, that's going to be, it's going to negative, but I'm going to square it, so it's going to turn positive. So we're going to end up with 9 quarters, right? That's the 3 halves part squared. Square root of 3 squared is 3. Okay, and then plus 3 halves squared is going to again be 9 quarters. And we have this whole thing under a square root. So this is going to be 27, right, over 4 plus 9 over 4. Okay, and if I didn't know any better, it's a 27 plus 9. That's going to be the square root of 36 over 4. That's a square root we could figure out. The square root of 36 is 6. The square root of 4 is going to be 2. 6 over 2, that would be, right, we've taken the square root, so I don't need to write that anymore. So that's just going to be 3. Okay, so this distance for this hypotenuse is 3. Okay, if you want to take a plus or a minus, and you're still stuck on that, that's okay. It's a hypotenuse, it's a distance, it's always the positive one. Okay, so anytime you're dealing with a triangle, it's like, was it plus or minus? It's always the positive one. Okay, because hypotenuses are distances, distances are positive. Okay, like why is this one negative? Well, I wanted to draw it on a coordinate system. So I'm not saying the length is negative, but I am saying the length does point in the negative direction. And why I need to do that is because I need to figure out what this angle is. So I need to know where on the coordinate system, here, 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 or here, where is this number? Okay, so we figured out the hypotenuse, the modulus. Okay, so the absolute value of z, which is just a distance between the origin and this point up here. Okay, that's going to be 3. Now we have to figure out theta. Okay, so what we're going to do is like, well, what relates the opposite side and the adjacent side to the angle? So wait a minute, I know that. That's a trig function. that's the tangent of theta, is equal to the opposite side, that's 3/2, divided by -3/2 times the square root of 3. Well, I hope you can see that this bit here is going to cancel. So we have the tangent of theta is equal to -1 over the square root of 3. Now, we're not done yet. Okay, so this is a partial answer. Okay, there's at least we're part of the way there. So normally, if your trait teacher says, hey, you got to rationalize your denominator, you do if that's your final answer. We're not at the final answer yet. So at this point, we're going to say theta is equal to the inverse tangent of -1 over root 3. Okay, now this is one of those ratios that you should technically know. Okay, if you had to memorize the unit circle, this is one of those that you're going to know. All right. If you didn't memorize it, I would recommend plug this in your calculator, but use degrees. If you did memorize it, then you can use radians and it's just fine. So we're going to end up with like, hey, isn't this theta is equal to -pi/6? That would be down here somewhere, right? That would be right here. This would be theta would be -pi/6. Well, this angle here is clearly not -pi/6, right? It's in the second quadrant. -pi/6 is in the fourth quadrant. That's just how that's how inverse tangent works, right? Inverse tangent gives you from -pi/2 to +pi/2. It's going to just give you stuff in this area, okay? So we have to now translate the answer we got to what the reality on the graph is, okay? So this is 30 degrees short, pi/6 short of pi. Okay, so what I'm going to do is say, okay, well, pi minus pi/6, that would be this part right here. Okay, this is -pi/6. So that would be 6 pi/6 minus 1 pi/6. What does that leave us with? That is 5 pi/6. So this angle here, that's 5 pi/6. Okay, so theta is equal to 5 pi/6. We're in the second quadrant. That's where we want it to be. Okay, that's where the negative signs come in. Okay, now what we have to do, okay, is we have to go ahead and throw this into DeMoivre's law. Okay, so DeMoivre's law, that says something like z to the fourth, right, is equal to, instead of foiling this out, which I would not want my students to do, and if you're watching this, you're doing this because you clicked on polar, complex numbers, polar form of complex numbers, you're not supposed to FOIL this out either, okay? So DeMoivre's law says something like, hey, that's going to be the modulus of z raised to the fourth times cosine of n theta. So n would be, what power am I raising it to? N times theta plus I sine times of n times theta. Okay, so all I'm going to do is say, well, that's 4 times 5 pi/6. Okay, so this is going to turn into 3, because that's the modulus that I got, to the fourth. And then we're going to have cosine of 4 times 5. That's 20 pi/6 plus I sine of 20 pi/6. All right, and that's how we're going to figure out our a plus b cosine, or a plus bi arrangement here. Now again, if you memorize the unit circle, all right, we could figure out 12 pi/6, okay, and then keep going. If you didn't, that's okay. Your calculator will do that. Now, this calculator is a little advanced than the ones that my students are allowed to use, and maybe the one that you're allowed to use in your trade class, okay? But I'm not going to use anything that's like advanced or too far above the term for it, okay? So actually, yeah. So what I'm going to do is I'm just going to say, okay, well, what is cosine of 20 pi/6? Or where is 20 pi/6? Okay, so 20 pi/6, where the heck is that? Oh, it's minus 24 pi/6, or 12 pi/6 would be right? 12 pi over 6. That's a fancy way to write 2 pi. 24 pi over 6, 24 over 6, that's 4. So all I'm doing is we run around the circle once, that's 12 pi over 6. We ran around the circle twice, that's 24 pi over 6. And then we got to keep going a little bit further, so it's 12 pi over 6. We can also reduce, okay? 20 times pi, that's going to be 2, well, that's going to be, that's going to be 2 times 10. That's 2 times 3. That's what 6 is. So that's going to cancel off, and we're going to get 10 pi over 3. That might be a little bit easier to see what's going on, right? So we have 10 pi over 3. Where the heck is 10 pi over 3? Well, there's 3 pi over 3. Here's 6 pi over 3, right? That's what's around the circle. 6 pi over 3 is a fancy way of saying 2 pi. So it's 6 pi over 3, 7, 8, 9 pi over 3 would be here, right? 9 pi over 3, which would be a fancy way to write 3 pi. That's over here. And at 10 pi over 3. So we're down here. Okay, so 10 pi over 3 is right here. That's 10 pi over 3. Our reference angle is pi over 3. So the reference angle is pi over 3. Going back to our unit circle and saying, okay, well, what's the cosine of pi over 3? Right? So, that's a half. But which quadrant are we in? You're in the third quadrant. So we have 3 to the 4th. Okay, that's 81. Okay. Cosine of reference angle pi over 3 is 1/2, but we're in the third quadrant. So it's negative 1/2. And then plus I sine, plus I. Now, what is the sine of pi over 3? That's going to be square root of 3 over 2. But again, we're in the third quadrant. So I lied. This should not be a positive sign. This should be a negative right here. All right. So we should have that. And the SIGN parts of this, the plus or the minus, that depends on where we ended up. You know, what is the angle we ended up with? That's what we track that. So the answer for this for my students would be something like negative 81 over 2 minus 81 over 2 square root of 3. That's our A plus BI format that people like to see for polar coordinates or for complex numbers, and that's what we'd have. So I think I have time for one more, so I'll do part number 2 for my graph. Actually, I'm going to stop this one here, and I'll start this one on a new piece of paper because this one's a little tricky. Okay, so thank you very much for tuning in, and I hope you enjoyed the video. Thank you for watching.